So let's have a look at the concept of area and volume. So first of all, we need to go back to 3 dimensions. So the first dimension of anything would be a line, 1 dimension, and it has a certain length. And if I draw a line across this whole thing, I know that it's an A4, so therefore it's going to be about 21 centimeters. Okay. So that's 1 dimension. So how do I make 2 dimensions out of that one line? Well, I get that line and I repeat that line all the way in, not the left to right, but the up and down. So I've got left and right, and now if I continue on, I have the whole sheet now up and down. 1 dimension and 2 dimensions. So an area is basically one line, 21 centimeters, and then it goes and covers a further approximately 30 centimeters. So how much have I coloured in 2 dimensions? Well, it's the 21 times the 30 that I went up and down. So area is a 2-dimensional line.
Area. Area is the space inside a 2D shape. We can't use units such as centimetres or metres because they only measure distances in a straight line. So, to measure area, we use squares. This shape has an area of 8 squares. Let's calculate the area of some other shapes. If we overlay a grid, it makes it easy to calculate. By counting, we can see that the area of the first shape is 15 squares, and the area of the second shape is 12 squares. But what if we want to calculate the area of a shape and there are no squares to help us? For example, this playing court. We will need to know the length and the width of our shape. The length is 7 meters and the width is 4 meters. The rule for calculating the area of a rectangle is length times width. So, to calculate the area of this rectangle, we must multiply 7 meters by 4 meters. 7 times 4 equals 28. The area is 28 squares. And because our measurements are in meters, the area is 28 square meters. So,
covering a certain area. Well, what's 3 dimensions then? Well, we've gone left and right, up and down, but now we need to go vertical, up and down. And so what would that look like? It would look like this, a book. And a book has many, many pages, vertical of 2 dimensions. So in this instance that we have here, the volume of this book is the 2 dimensions that are here, my A4, by how high it goes up and down. So it's 21 times 30 times the height, and I'm going to say approximately 3. So the dimensions of this is basically a line in left and right going across up and down, and then the whole sheet is now coloured in and it goes vertical. So that's how we get a volume. So an area equals 1 dimension times 1 dimension, and a volume is a dimension times a dimension times a dimension, 3 dimensions. So the concept that we're getting across here is that volume and area all come back to a line. one dimension. So where can we go with this concept? Well, some things, like my coffee cup, well, the dimension in one dimension is a line that is a circle. And the circle goes out a certain way, a radius. So with some things that we see, it is the area of the base is my first dimension, and that can be deconstructed into a series, much like a wood and its rings, into a series of lines. So it is a circle that goes that far from the center out, ever enlarging to the edge. How do I get the volume of a sphere? A cylinder. Well, it's a circle, layer upon layer upon layer, and imagine that this is, in a sense, a whole bunch of coins. And each coin has here. So it's to work out the volume of a cup. Well, the volume of a cup equals the circle times the height. How many layers it would be. And so it's the area of the circle. And if we take it a little bit, there's some fancy mathematics and calculus and so on, differentiated practice, that you see, how do I get the area of a circle? Well, really, how I get the area of a circle is I get a circumference of a circle, and I go out in one dimension, the radius here. So let's go for other sort of shapes that we have.
All you have to do is find the area of the original 2D shape that got extended and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle and its dimensions are 4 centimeters by 3 centimeters. So to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40, so the area of the triangle is 40 inches squared. Now all we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters, so if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle was extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of this cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape and then you multiply it by the length that it was extended, and that gives you the volume.
What about finding something a little bit more obscure, like a cone, or pyramid, or those sort of things? Well, let's see if we can find answers to that. Well, it's got something to do with the base. and it's something to do with the height, but we've got to do something else. So what's your guess? So let's have a bit of a look. So we have here, you know, a cone shape. So it is, you know, it's a circle, but ever diminishing over a height. Now, if I draw an equivalent cylinder, it might look something like that. Well, it's obviously going to be less than a cylinder. Now, the volume of a cylinder, we learnt, is the area of the base times the height. So the volume equals the base times the height. I'm glad you're reading upside down, by the way. So is the volume here equal something, common fraction actually, of the base times the height? Well, it's really not actually of the base. It is actually the volume equals the base times the height times an amount. So I'm getting you to think. So I'll pause the video and get you to, is it a half? Is it a quarter? Is it a third? Is it a fifth? What do you think? Well, I don't know. So let's answer that question. And we're going to do it in a physical form. So I'm going to insert a little video and you'll be surprised. So I wonder if you got it correct. Here we go.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
Well, there you go. 3 cones fitted into the cylinder, so the area of the volume of a cone is 1/3 of that. So if you got 1/3, well done. I wonder if that applies to other types of cone type shapes. Well, let's go back to our drawing. And as I say, thank you for reading upside down. So we've decided that the volume of a cone is the base, or is 1/3 times a third here or a third there. It doesn't really matter, but it's commonly expressed this way. So that's 1/3 here. So the question now I'm going to ask you, what about something like this? A pyramid. That's a cone type shape, isn't it? But the base isn't a circle. The base is a rectangle. Well, or it could be a square, usually a square with a pyramid. So how would that be? Or something even more obscure. So let's make something, this has got a hexagonal base, and it is like a point on a end of a pencil, for example. There's your pencil going down like that. So the end of that pencil, that has a base, which is a hexagon. Well, the rule is the same. The rule is the same. The volumes of cone type objects is 1/3 of the base times the height. And it's common for all of those. And in that sense, you could fit into the video, you could fit 3 cones into a base, into a cylinder, and you can fit 3 pyramids into a rectangular prism. And you can fit 3 of those into, obviously, a shape of a hexagonal type prism. So that third seems to be fit with geometry of volume. Let's go to our sphere. Now our sphere, it's a ball made up of a circle, isn't it? let's think about this. Well, it's a circle, and remember we talked about circle being a circumference in a certain dimension. Well, it goes that way, and also goes 2 dimensions that way. And it's, you know, it's not, you could fit a ball inside some sort of cube, couldn't you? In 3 dimensions, because it's a circle inside a square. But in 3 dimensional, we can fit a sphere inside a cube. So how does that work? So let's see if we find a video on that. And I'm going to give you a clue. That third gets involved again.
This video will demonstrate the ratio of volume of a cylinder and a volume of a sphere. We have a cylinder and a sphere with the same height and diameter. Fill the cylinder with water and push the ball into the cylinder. The volume of water left in the cylinder is 1/3 of the original volume. That means the volume of the sphere is 2/3 of the volume of the cylinder.
Well, there we have it. We have that a sphere is 2/3 the volume of a cylinder. So what's that mean mathematically? Let's come back here. So we have a sphere here. Can I go back one step? The area of a cone was 1/3 the base times the height. The volume of a sphere is the whole 1 base times the height. Well, what's the volume of a sphere was the question here. And we've decided that that equals the volume of a sphere equals 2/3 the base times the height. So that 1/3 seems to fit in terms of the geometry and the calculation of those things. So we've gone conceptually now, and hopefully you've seen how we go from 1-dimension line into 2-dimension area, into 3-dimension volume, and we've had a rule that's applied that the area of the base times the length of the object, this time the height, creates volume. And we then said, well, let's have a look at some particular shapes. And the particular shapes of conoid and circular shapes has this 1/3 involved. So conoid shapes are so pyramids and cones, for example, are conical shapes are 1/3, and a sphere is 2/3. So this has been all tested, and it's saying it's true no matter what sort of shape. So here's the benefit. There's a cheat sheet that you can use, and they're the formula of volume. So once you understand what the terminology is about, once you understand the concept, then you can use with confidence or the formula that we're about. So let's pull up on the screen the formulas that you're going to use. So there they are. You have square, rectangle, triangle, trapezium, and rhombus, and a particular sort of shapes. So therefore the area that you can use. So knowing and inserting the base times the height, writing the formula down, gives you confidence in that. For volume, we have the volume ones, the rectangular base prism, cone, pyramid, and the sphere. So they're the common ones that you can now use with confidence as you do your mathematical measurement of space.